everyone. Welcome to week 11 of the live problem solving sessions for traffic engineering. I'm Sethi Vinayagam, a PhD scholar in the Department of Civil Engineering at IIT Madras. Okay, let's begin with an overview of concepts and topics that were covered in week 11 lectures. Okay, so this week we had two major topics that were discussed. So one was on parking management, which the first three lectures covered, and the second part was on road safety. Lectures 3 to 6 covered those topics. Okay, so in the first lecture, parking management, so we started off with the need for parking management, right? So why do we need to worry about parking? It's because parking. So what is parking? First, parking is stopping the vehicle, then disengaging from the vehicle, that is you leave the vehicle and then you leave it unoccupied. Okay, so and then this leaving it unoccupied should last for a certain duration of time, right? If it is very short, we do not consider it as parking, right? So if the vehicle is stopped, disengaged and left unoccupied for a certain period of time, so then we call it parking. So why parking management is needed is because this can affect the traffic congestion, right? So because the vehicle ownership rate is on the rise, right? So we know vehicle ownership is on the right, but available space generally for road infrastructure, including the parking space, is limited, right? So this does not grow at the same rate as the vehicle ownership is growing. So the demand for parking space is growing at a higher rate than the supply that is provided for parking, right? Therefore, if this is not attended to, then this can lead to severe traffic congestion, and not only congestion, it can also congestion is one of the problems that it could create. So other problems could be safety issues, right? So improper parking on the roads can also lead to crashes, right? And also it can obstruct the traffic movements for emergency services like police vehicles or ambulances, right? So these are some of the issues that are associated with improper parking management, and that's why we need to study this and take care of it. And then we were looking at the different types of parking, right? So when it comes to parking, there are two major categories. So one is on street parking, another one is off street parking, right? So on street parking means where vehicles are parked along the road where the main traffic flows, right? So it is on the side of the road. There is some space that is left for parking the vehicles, right? So this area is used for parking. So this is on street parking, which means it is along the road where the traffic flows. So off street means it is away from where, so there will be a dedicated parking space away from where the main traffic flows. Okay, so that is our off street parking. So there is some separation between the main traffic flow and the parking that is available. So within on street parking, we have three different types, right? So one is parallel parking, perpendicular parking, and then angular parking, right? So parallel parking means if we consider this to be our road, okay, so this is the direction of vehicle movement, let us say this way. So if the vehicles are parked along the length of the road, right? So this is the along the longitudinal direction of the road the vehicles are parked. So this is called as parallel parking. Okay, so perpendicular parking means the vehicles are parked perpendicular to the length of the road, right? So this is perpendicular parking, and angular parking is in between this, right? So in parallel parking, the angle is 0 degrees, right? So it is parallel to the uh, road. Perpendicular, it is 90 degrees to the length of the road, and angular parking, it will be in between, right? So this is your road, so it could be at some angle, right? So this could be 30 at 30 degrees, 45 degrees, or 60 degrees, right? So there are different advantages and disadvantages associated with each of them, right? So in parallel parking, right? So the width that is consumed, the width of the roadway that is consumed for parking will be less, right? So the capacity of the roadway is not reduced uh, a lot in parallel parking, but the downside is the number of vehicles that you can park in a given length of the road will be limited. So compared to parallel parking, the perpendicular parking, provides advantages for the parking in terms of the number of vehicles that can be parked, right? So because if you look at it, each vehicle consumes only a very little amount of the curb space, right? So more number of vehicles could be parked in a given length of the road, but the disadvantage is, higher, width is taken up by the vehicles, for parking. So the capacity of the roadway reduces greatly. So angular parking, this provides, an intermediate, a trade-off between the number of vehicles and the width that is occupied by the vehicles, right? So between the parallel and the perpendicular parkings. So these are the different types of parking that we were looking at, and then we were looking at some different types of parking surveys that can be done. So why do we do the parking surveys? To get an understanding of what is the demand for the parking in a given location, right? So how many people want to use it, right? So if we have an idea of that, so we'll be able to design the facilities in a better way, right? So one we can focus on the demand side to know how many people want to use the parking spaces. The other one is what is the existing level of parking supply that is available, and what are the different uh, you know uh, like barriers or restrictions that are there that we need to keep in mind when we are developing the parking facility. Okay, so for that, the parking surveys help. So within the parking survey, for particularly for demand, so we were looking at different types of surveys. So one is the occupancy survey, right? So as the name suggests, occupancy survey is done to see how many vehicles or how much of the parking supply is occupied at a given period of time, right? So if we have a parking area that is available for say 10 vehicles, right, at a time. So if we will pick a duration, say for example 15 minutes or 30 minutes, and see how many of these parking bays are occupied by the vehicle. Say 5 vehicles are there during the survey period, uh, and 10 parking bays were available, then the occupancy is 50%, right? So only 50% of the supply is utilized or occupied, right? So such surveys will tell us about the adequacy of the parking supply facilities that are currently in use, right? But the disadvantage is we will not know, how many uh, unique vehicles are there, or how long each vehicle is staying, right? So we only know about the period of survey that we are measuring. Okay, so then we also have beat surveys. So beat survey, we collect little more detailed information, right? Where we record the vehicle registration number, the license plate number, right? So, and then also this is done at a different at a certain frequency. That frequency is called as the beat frequency, like every 15 minutes, every 30 minutes, 45 minutes. So we predetermine this frequency, and then for every period of this beat frequency, so we go and collect this information on the time at which we are recording it, and what type of vehicle, what is the license plate of the vehicle that are currently present in the parking area. Okay, so what does this allow us to do? Because we are recording the license plate number, so we can look at different periods where we have taken the observations and then see how long a particular vehicle has been observed, right? So this tells us a little bit more about the duration of stay for individual vehicles, right? So still it can be a little bit off from the actual time that a particular vehicle occupies the parking area, because we are not taking these measurements continuously but only at a certain periods, right? So if the vehicle leaves between the period of observation or arrives between the period of observation, so the duration of our measurements can be off, right? So finer resolution will give us more accurate data, and coarser resolution of this beat frequency will give us more little bit of from the actual duration data. Okay, and so we can have undercounts basically. So if some vehicle is occupying the parking area, for less than our beat frequency. For example, if we are going to survey every 15 minutes, say 9 o'clock we took an observation, and the next observation will be at 9:15. If some vehicle entered the parking area at 9:02 and left at 9:13, so this vehicle will be totally will not be counted at all in our survey, right? So this can lead to undercounting, especially when the beat frequencies are large and the vehicles are staying for shorter durations, right? So we can alleviate this disadvantage by reducing the distance or increasing the beat frequency. And also we can improve on this further with continuous survey observations, continuous observation survey, where you record every entry and exit from the parking area, right? So you record the license plate, the time of arrival, departure, and the type of vehicle of every entrance and exit from the parking area, right? So this will tell you exactly how many vehicles were present at each point in time in the parking area and for how long each vehicle stayed, right? So this requires collecting data frequently, continuously. It can be done using video cameras and then analyzing the data from the video footage. So those were covered in the first lecture. The second lecture we were looking at how do we analyze this data, right? So we know how to collect the data, right? So through the surveys for the parking demand, but how do we represent it, right? So what kind of measures do we use when we are talking about parking demand? Okay, so one is so with respect to data representation, so we have different ways. So one is parking accumulation. So what is parking accumulation? So here we look at how many number of vehicles are present at a given point in time in the parking location. Okay, so if you look at a graph of this, so here the y-axis would be the number of vehicles parked, near x-axis will be time. Okay, so this will give you some profile something like this. Okay, so at any given point in time, right, the graph, the y-axis will tell you how many vehicles were present in the parking location. Okay, so that is the parking accumulation. This is one way of representing it. Next is parking volume. So what is parking volume? Parking volume is nothing but parking accumulation is for a given point in time, right? Whereas parking volume is this accumulation of the parking over a period of time, right? So if you take a given period, say from T1 to T2, so in this T1 to T2 period, how many unique vehicles were present in the parking location, right? So this is the count over a period, right? So that is the parking volume. Third one is parking load. Parking load is nothing but you take the area under the parking accumulation graph for a given period. Okay, so this is nothing but how many vehicle hours have been utilized, right? So the y-axis gives you the number of vehicles parked, right? So the x-axis gives you the duration elapsed, right? So the area between the area under the parking graph will tell you how many vehicle hours have been used or occupied, right? So that is the parking load. Then we have average parking duration. So average, so different vehicles take different amounts of time, right? So not every vehicle will stay in the parking location for the same amount of time. So we can look at the average duration for over a period of time. So what do we do? So this parking load, what does this tell? This tells us total amount of time that have been occupied, right? So number of vehicle hours. Okay. So if we divide this by the volume, so volume is total number of unique vehicles that have been observed in the given duration. Okay, so the load by volume, it will tell you what is the average duration of parking for for any vehicle in the uh, in the period of analysis. Okay, so that is one way, one of the measures. And then we have average turnover, right? Turnover, sorry. So what is turnover? Turnover is how many unique vehicles have been parked at a given parking bay in the period of analysis, right? So if you're analyzing every 15-minute periods, right? So 0 to 15, say 15 to 30, and let us say there are two parking bays in an area, okay, and say V1 for first 15-minute period there was a vehicle V1. In the second 15-minute in the second bay there was another vehicle V2, and in the second 15-minute period in bay 1 some other vehicle V3 was there, but in bay 2 the same vehicle V2 was present. So which means that the turnover in the 30-minute period for bay 1 is 2 because two unique vehicles were present, whereas for bay 2, even though whole 30 minutes are occupied, it was occupied by only one vehicle. So the turnover for bay 2 is 1, right? And if we take the average of this, so it will be 3 by number of bays is 2, so 1.5 is the average turnover. Okay, so this is the number of unique vehicles that is served by on a per bay basis, right? So each bay, how many unique vehicles are served in the period of analysis, that is your average turnover. Then we also have the parking index. So this is also called as occupancy or efficiency, right? So this is how many of the bays are being utilized, right? So again, in this particular example, the occupancy is 100%, right? So we have two bays, right? So how many are occupied? So let us say I have number occupied. So both the bays are occupied in the first 15-minute period, and in the second 15-minute period also both are occupied, right? So here we are not looking at distinct vehicles. Here we are looking at how many bays are empty or not empty. Okay, so 2 out of 2. So the capacity is 2, right? That is the total number of bays. So the occupancy is 100% for each period, and the average occupancy is also 100%. Okay, so this tells us about the efficiency of a base. For example, if only say 10% of the base is empty, which means we have excess capacity which is not being utilized, right? So we have too much parking bays that are available. On the other hand, if you are constantly having 100%, so you can say that it is efficient, but it can also mean that some of the parkings are parking demand could have been denied, right? So because the parking bay was never no empty parking bay was available, some demand that could have come in when all the bays were occupied might have been turned down. Okay, so that this gives an indication of how well the parking space is being utilized. Okay, so that's with respect to representation of the data. Then we are looking at street inventory surveys. Okay, so this is related to the supply side of it, right? So here, before we decide about what kind of facility that we provide, or how many parking locations should be provided. We should know what is the current condition. Okay, so here we look at what are the uh, um, you know you look at a length stretch of the road, and then in that stretch of the road we look at for continuous items and point items occupying the stretch of the road, right? So which could act as restrictions for the parking, right? For example, when it comes to continuous items, so we look at are there medians present, median dividers, or for the pedestrians, are there any guardrails, whether any road markings are there, or some or any other security requirements that are present, for example near schools, hospitals, or any government offices. So those are continuous items because they occupy a long stretch of the road. Okay, and then for point items we look for things like, is there any driveway, bus stops, or signposts, any pedestrian crossings. So these are located at a single point along the roadway. Again, why do we measure, take into account of all this? Because we cannot provide the parking spaces that hinder these items, right? For example, if you have a pedestrian crossing and you're providing parking over there, so it's going to affect, people, crossing the road, right? So we take a stock of what are these continuous and the point items that are present along the stretch where we are interested in, providing the parking supply, and then we take into account when we are designing our parking locations. And then so we were looking at derivation of the parking plan, right? So when it comes to parking plan, so we have to, once we have collected this data, right? So first we look at what is the total stretch of the roadway that we are surveying. So that is L1, right? So this is the total length of road. And then we look at, once we know what are the continuous items and the point items, we look at what are the where are the parking restrictions, right? So what is the total length of what is the total length of the restricted areas for parking, right? So that is L2, right? So if there is a median divider, right, so we take the length of the median divider, and after some place there could be a school, so the width of the school along the road, so that should be also subtracted. Okay, so L2 is the sum of the lengths where the parking cannot be provided, okay, because of this, either the point or the continuous items. um, and then we also take into account L3. L3, so this is not from the this L3 is also the length of restricted location, but it is not coming from the continuous or the point items that we discussed. This is restriction from capacity, right? So based on capacity consideration, so wherever we cannot provide the parking due to capacity alone, right? So for example, if the road is very narrow, right? So providing parking there will decrease the capacity even further, right? So those locations we cannot provide parking, right? So those based on the width of the road, and also the traffic volume. So in some areas we cannot provide. So the length of those locations is L3. Okay. So with all this, so the total available length for parking would then become L1 minus L2 minus L3. Okay. So this was the total length of the road that was surveyed. L2 is restrictions due to the continuous and the point items that are present on the road. L3 is restrictions due to the capacity and the traffic volume constraint. Okay, so you remove those, and whatever is left is the length of the curb space along the road that is available for providing the on-street parking, right? So that is how we come up with the parking plan, right? So once we know the length that is available, So on this link, so we have to now decide whether we have to go for parallel parking, perpendicular, or a angular parking. Again, we're looking at the demand as well as the interference with the traffic flow. Then in the third lecture, so we were looking at some traffic strategies. Okay, so here, so we are looking at what are the different kinds of policies that we can adopt to manage the traffic. Okay, so the main policy when it comes to the strategies for managing traffic is pricing. Right, so this is one of the effective uh, strategies that we can adopt. Why? Because the parking demand is directly influenced by the parking rate. Right, so for example, in the we can have different rates for peak and off-peak periods for the same location where parking is done. Right, so we can have a base price. Right, so we can have a base price plus a variable price. This variable price is time dependent, right? So during off-peak hours, this variable price can be higher, and during the peak hours, variable price can be higher, and in the off-peak hours, variable price can be lower, right? So what does this do? So when the price is high, right, so the number of people wanting to use the parking space will come down, right? So because people do not want to pay too much, right? So so that way we will be able to control the demand for the parking space during the high traffic peak period. Whereas in the off peak period, so generally the traffic volume is going to be lower, so the demand for the parking space will also be lower. So in that case, we can reduce the this variable price so that so the demand is still under control in that situation as well. Second policy is having strict enforcement. For example, people who are violating the rules and illegally parking, so we can put stringent fines so that that acts as a detriment for people to violate the rules, right? So strict enforcement is one of the effective policies. And the third one is we have looked at transit services. Okay, so providing or improving transit service enhancement, right? So if transit provides better connectivity, right, so people don't will have less people will may choose to go with transit instead of taking their own vehicles, right? People bringing their own vehicle is what is creating the demand for the parking location, but if they are taking the transit service, then the demand for the parking location directly comes down, right? So so we could provide better public transit services. And finally, we also looked at park and ride. So what is park and ride? So park and ride is basically you provide sufficient parking space that is away from the CBD area, right? So that is not exactly at the CBD, but it is located at some distance from the commercial locations, right? So people can park their vehicles at this location, and then they can go to the commercial location, taking the transit ride, right? So efficient transit service can be given between this parking location and the commercial activity location. So people can park their vehicles outside the CBD and then go into the CBD and come out by making use of the transit services. Okay, so these are some of the measures. So we looked at more strategies that we were introduced to, and then we were also looking at different parking signs that are used for different situations as given in the IRC 672012, right? So for this we looked at IRC 67 2012, and yeah, then so this is all with respect to on street parking is what we were focusing on till now. And finally we were looking at developing off street facilities, right? So as we said, what is off street facility? Uh, it is a dedicated parking space, right? It's not where the parking is not done along with the traffic. It is done the parking location is separated from the the traffic flow, right? It's not along the road. So here we can have different types of off street facilities, like one is surface parking, So where the parking is provided at the same level or the ground level, and then we have underground parking, and we have multi-story parking. So this is all governed by the demand that is there for parking and also the space availability, right? So for example, if you have to provide surface parking, you'll have to acquire the amount of land that is required to provide given number of parking. And so when you go for multi-story parking, the amount of ground space that you require will be smaller. So you can have multiple floors that you can provide for parking, and then you can have roof parking and also mechanical parking. So these are some of the different types of the off-street facilities that can be provided. Okay, so with that, the parking management part comes to an end. So then we moved into the second part for this week, which was focused on traffic safety. Okay, so why is traffic safety important? Because it uh, road crashes is one of the leading causes for fatalities around the world, right? For example, especially the scenario in India is much worse, so where we have around 1.5 lakh deaths per year because of road accidents, right? So that is a very sad scenario, right? So that's why road safety is one of the important issues, right? So the goal of traffic engineering, right, if you recall from the first introductory lectures, so safety is one of the primary objectives, right? So safe transportation is one of the primary objectives of traffic engineering, right? So safety is a important topic that we have to look into. Then we are looking at what are the different causes of road crashes, right? So different factors lead to this. So we can group them into 5 different categories. So one is uh, human errors or faults of the drivers. Okay, drivers or the road users, right? Second one is inadequate infrastructure, right? So this is with regard to the facilities, right? So when the designs are not proper, right? So they can lead to unsafe conditions. Third is vehicle related factors. So these are accidents caused due to vehicle errors like vehicle malfunctions, like maybe due to improper maintenance or something. Right? So these are vehicle factors. Then we have environmental factors. This could be due to like weather related. Then hospital post care facilities, right? So if this is like how the hospital, how far the hospitals are located and the quality of the treatment that is provided. This is important, right? So because this can if the hospital care is not proper, right? So injuries that could have been prevented from being fatal can turn into a fatal accident, right? So this is also important. And then finally we also have what is the enforcement level, right? So if the laws are not properly enforced, right? So then people will easily violate it, and that can also lead to crashes, right? So these are some of the common factors that we came across. Then we focused on human factors, how human related factors are affected. Okay, so when it comes to human related factors, so sleep, distraction. So these are major things that we have to look into, right? So when the drivers are not attentive, to what's happening on the road, right? So then it can cause accidents. So one is sleep. Other one is even if the driver is not sleepy, but distractions from other factors like using cell phones, or talking with the passengers. So those can distract the drivers, and that can also lead to accident. So when it comes to the factors, so we have the driver, vehicle, and the road system interaction, right? So the driver will have to see what's happening on the road. So the PAEV process happens, right? So the perception, intellection, the emotion and the volition, right? So if this process happens, so the reaction will take place, and the driver will respond to those situation that is happening on the road, and the response will be through some action, right? So for example, braking or maneuvering, and then the driver will receive the feedback and then respond again. So this is how the driver will be making that or adjusting to the environment. So here different characteristics of the driver and also of the system will affect this process. One is driver characteristics, so which is like visual acuity, hearing. So these are the two major things, right? And also maybe reaction time. So these are physical characteristics of the driver, so that will affect this process. Then we have so vehicle characteristics will so here we are only talking about human characteristics, and also the physiological characteristics. So these are physical. Physiological is like like the patience level of the driver, whether the driver is angry, right? So or if the like the feelings, if he is fearful of the situation. So all these will affect the this process. Then we have the different environmental factors that are related to road. So all these were covered when we are talking about what affects the human characteristics. So then we were looking at road safety engineering and crash data, right? So how do we actually deal with improving the safety of the road system? Okay, so here we have majorly looked at two ways. One is the proactive approach, so where before accidents happen, so you are analyzing the road, right? So you are conducting regular audits. You have different surrogates of measures of safety to surrogate measure means it is like an alternative measure, right? So if that measure is bad, right, so that that can lead to accidents, right? So you analyze this data, right? So you do it frequently. You identify locations that are prone to accidents, and then you take steps to address it. So what this is proactive, because you are doing it before accidents are happening. So this can lead to preventing accidents. So the other approach is reactive approach, so where you are reacting to the situation, right? So once the accidents are happening, you are collecting the data, then you are analyzing why those accidents happened, what led to those accidents, and then you are trying to address it, right? So here this can prevent future accidents, but some accidents have already occurred, right? So this is a reactive approach. You are reacting to so what is happening on the field. So finally, we were looking at black spot analysis. So what is a black spot? So black spot is like locations of serious accidents. Right? So as per the definition, so it is so if you take a highway, so a 500-meter stretch of the highway where five crashes have happened or 10 fatalities have occurred. Right? Fatalities means deaths. Crashes can include both fatal crashes or just injuries, right? So in the past 3 years, right? So all those 500-meter stretches where this condition is satisfied, so those are identified as black spot. Okay, this is as per the definition from the MORTH. Okay, so these are areas that are highly prone to accidents, right? So frequent accidents of high severity can happen at these locations, right? So we have to focus on these locations with more care. And then we were looking at different methods of identifying these black spots. So we were looking at techniques like crash frequency method. So we look at how many crashes happen in a given period of time. We are not looking at the fatality of the crashes. And then we also look other methods include fatal crash frequency method. So here we are only looking at the fatal crashes, not worried about the minor injuries or grievous injuries. So how frequently the fatal crashes occur. Then we have the EPOD method, equivalent property damage only method. So where all the different accident types, they are converted into an equivalent property damage, right? So we convert it into monetary measure. right? So we have fatal accident means it is equivalent to this much amount of money. Only if property is damaged, it is equivalent to so much amount of money, right? So we have relative, weightages for different accident types, and then we take the weighted sum of each accident type, and based on this weighted sum, we can compare different locations which are more prone or less prone to the accidents. And we also looked at some upper tail critical test, right? So these are the different techniques that we were looking at to identify these black spots. Okay, so with this overview, we can move into some of the problems related to this. So the first question for this week is we have to accept or reject this statement. Parking supply surveys are useful in determining the short-term parking demand. Okay, so we have to say whether the statement is right or wrong. Okay, so here we are talking about two different things. So one is supply, other is demand. Okay, the survey. So supply is basically what? Supply is from the system side, right? So how many parking bays or parking locations are available, right? So here we are talking about the capacity, right? So available capacity. So that's what the parking supply refers to, right? So demand is from the user side, right? So how many people want to use the parking location, right? How many people want parking areas? So this will tell us available capacity. This is how many users want to park. Okay, so parking supply surveys will tell us only about the existing capacity that is available to us. Okay, it does not tell us how many people want to use, right? So this parking supply survey cannot give us any information about the demand. So for demand, we have to do demand surveys where we look at how many people are how many vehicles are actually being parked. Okay, so this is not going to tell us anything about the demand. Okay, so this is not helpful in determining the short term parking demand, so therefore we reject the given statement. The answer is option B, reject. Okay, so second question is the parking survey data collected from a parking area for an hour, right, in 15-minute intervals by license plate method is shown in the table. Okay, the table is given here. Each cell indicates the license plate number of the observed vehicle, if any. Okay, so in every cell, so we have a number. So this number is the license plate number. Okay, so different number means it is a different vehicle, right? So if the same number is repeated in two cells, it means the same vehicle is occupying the same duration. Okay, so the question is we have to find the average turnover, the average occupancy, and the parking load. Okay, so let's recall what turnover is. Turnover is nothing but number of unique vehicles per bay, right? So this is turnover. Okay, so what is occupancy? Occupancy is percentage of bays occupied, and then load is area under accumulation curve. So area is nothing but it will be the product of accumulation and time, right? So for how long each vehicle uh, has been occupied, right? So we take the sum of all that, so that will be nothing but accumulation into the time of the accumulation. So that is your load. Okay, so that's what we want to find out from this given survey data. Okay, so first let's see how to get the turnover. So for each bay, let's see how many unique vehicles are there. Okay, so for bay 1, so there is only one vehicle. Okay, bay 1 has served only one vehicle. Bay 2, so there is So 2365 is one, 9874 is there for two analysis periods, and then 8554. So there are three unique vehicles. So for bay 3, there is only one unique vehicle that has been occupied for 45 minutes. Then for bay 4, again only one vehicle for 30 minutes. Bay 5, one vehicle for 30 minutes, followed by another vehicle for another 30 minutes. So two unique vehicles. Bay 6, one unique vehicle. Bay 7, two unique vehicles. And bay 8, one unique vehicle. Okay, so this is the turnover for a given bay, right? So what we want to find is the average turnover. So we have to take the average of this. What is the total turnover? It is 3, 4, 5, 6, 8, 9, 11, 12. Okay, so 12 is the total turnover. Okay, so average turnover is with respect to number of bays. Okay, so average turnover will be 12 over 8, so that will be 1.5. Okay, so for any given bay, so the average turnover is 1.5. So each bay is serving 1.5 number of vehicles on an average. Okay, unique vehicles on an average. Second question is, what is the average occupancy? So occupancy is how many bays are occupied in a given time duration. Okay, so here we have to look at for each time period, okay, separately. So here let us look at occupancy. So in the first time period, how many vehicles are occupied? 1, 2, 3, and 4 vehicles, right? So 4 out of the 8 bays are occupied, right? So 4 bays are empty. So the occupancy for the first 15 minutes is 50%, right? So it is 4 out of 8, so which is 50%. Okay. For the second period, how many vehicles are there? So we have 1, 2, 3, 4, 5, right? So 5 out of 8 vehicles are occupied, so which is 62.5%, right? So that is the occupancy for the second 15-minute period. For the third period, there is only one empty bay, right? So it means 7 out of 8 bays are occupied, so which is 87.5% occupancy. And for the last period, we have 3 empty bays, so which means it is also 5 out of 8, which is 0.625. Okay, so this is the occupancy per analysis duration. Okay, for every 15-minute period. So what we want is the average occupancy, right? So for the whole 1 hour, what is the average? So we have to take the average. So that is nothing but 0.5 plus 0.625 plus 0.875 plus 0.625 all divided by 4. So that is 0.656. So 65.6%. So on an average, 65% of the bays are occupied by vehicles, during this 1 hour period. Okay. And the third one, parking load. For parking load, what we have to do? So we have to look at the accumulation into time, right? So what is the accumulation? So accumulation is basically the numerator that we have used for the occupancy, right? So how many vehicles are occupying the parking area? So that is your accumulation. So the time period is fixed for every period. So if t is your time period, so that is 15 minutes in every period, because our analysis period is fixed, right? So it is every 15-minute intervals, right? So we have to look at the accumulation and then multiply it by the time period, so which is constant. So for the first period, accumulation is 4 vehicles. For the second period, it is 5. Third period 7, and the fourth period is also 5. Okay, so this is the total number of vehicles, and in every period, so they were occupied for 15 minutes. Okay, so generally we report it in terms of vehicle hours. Okay, so we convert this into hours. Okay, so which means that, so this will be 4 times, so this will reduce to 5.25. The unit is vehicle hours. Okay, so this is the total parking load for the given hour of the analysis. Okay, so with that we have solved all the questions that we are needed to from this survey data. Okay, so the first one is 1.5. This is the average turnover. 65.6% is the average occupancy. 5.25 vehicle hours is the average or the total parking load. Okay, third question is you have to match the items given in column X with its corresponding items in column Y. So in column X, we are given some terminologies related to the road safety. Okay, column Y, we have to some description of those terminologies. So we have to match them correctly. So we have primary crash data source, reactive approach, proactive approach, secondary crash data source. In column Y, we have surrogate safety measures, record from insurance companies, police reported crash database, report road safety audit, and crash severity models. Okay, so first, what is the primary crash data source? Primary crash data source is the police reported crash database, right? So this is the primary data, primary source of data that is used in all the analysis, right? So because all the accidents will be recorded by the police, right? So the FIR will contain the information of, when the accident happened. It will contain a summary of, the accident, right? So this is the primary data source that is used in the analysis. Second is the reactive approach. So reactive approach means here we collect the crash data, right? So which means it is after the crashes have occurred, right? So this is not before, this is after the crashes have occurred. So we collect the data and then analyze that to come up with the solutions. So which means that this must be E, right? Because we build this crash severity model. So crash severity models will tell you, for a given set of factors, under a given set of factors, what is going to be the severity of the crash. Okay. So in order to build these models, so we need the prior data, right? So or the observed data, right? So that will be only a reactive approach because the data can be collected only after the fact. Okay. So therefore, it will be a reactive approach. Building the crash severity models will be a reactive approach. The third is proactive approach. So this is the opposite. This is before the crashes have taken place. So which means that we need to have some surrogate measures which indicates that if the measure is the surrogate safety measure is bad, so it should indicate it's an indication that the situation or the location is prone to accident. We need to take some steps, right? So which means this is before the fact, right? So therefore this is a proactive approach. And one more thing, so D, road safety audit, right? So that is also a proactive approach. So road safety audit means which means we are going to, in regular intervals, we are going to conduct this audit to take stock of what is the current scenario. If there are any safety issues at some locations that we need to take care of, right? So which means this is also a proactive approach. And finally, we are left with secondary crash data source. So this can be taken from the insurance company records, right? So people claim insurances, after crashes and accidents. So that can be used to augment the crash database information, right? So from the police database, whatever we had, that can be augmented from what is coming from the insurance companies, right? So which means this is secondary data source. So the right matches 1 matched with C, 2 matched with E, D matched with both A and B, and 4 is matched with B. Okay, so that is given in option B. So B is the right answer. Okay, question number 4 is which of the following statements are incorrect? Okay, so the statements are road environment related factors are least responsible for road crashes. B, as per WHO global plan, the target has been set to reduce the number of road fatalities and serious injuries by 50% within 2030. C, adequate post-crash care facility has an impact on crash occurrences. And D, Moth defines black spots as sites with 5 road crashes or 10 fatalities in the past 5 years. Yes, we are looking for incorrect statements. So first statement says environment related factors are least responsible for the road crashes. So this is incorrect. Okay, why? Because so if you look at which uh, factors are more severe for the road crashes. So we have three major factors. So one we already know, it is the human related factor. That is the most severe one. Okay, most responsible one. One that is the human related factors. The second is the environmental factors, the road environment. This is the second most responsible factor. Final one is vehicle related. Okay, so vehicle factor. So that is the least responsible. If you look at what is the cause of the different crashes, so human factors is the most responsible one, right? So most of the crashes are due to human related factors. Then it will be road related factors, and finally the least ones are vehicle related factors like mechanical errors or malfunctions. Okay, so road related is not the least; it is the second most. Okay, so A is incorrect. So B, as per WHO Global Plan, the target is to reduce the number of road fatalities and serious injuries by 50% by 2030. So that is correct. So that is true, the given statement. C is adequate post-crash care facility has an impact on crash occurrence. So this is not correct, right? So here we are talking about post-crash facility, which means once the crash has taken place, how well we are able to treat the victims. Okay, so which means that this is only going to help people who are affected by the accident, right? It's not going to uh, have any impact on the occurrence. Okay, occurrence has to be occurrences before the crash has taken place, right? So having better post care facilities is not going to reduce the number of accidents. It is going to it can maybe reduce the severity of the accident. Okay, so maybe protecting people from fatalities, so that can be impacted by the post care facility, but not the occurrence. So occurrence has to be affected by the factors that we are talked about here, right? So the human factor, road factor, vehicle factor. So these affect the crash occurrence. Post care facility will affect the crash severity. And D is Moth defines the black spots as sites with 5 road crashes or 10 fatalities in the past 5 years. So this is incorrect. So part of it is correct. So the 5 road crashes or 10 fatalities is correct, but number of years is wrong. It should be 3 years, not 5 years, right? So therefore D is also incorrect. So only B is correct. All the rest of them is incorrect. So the question was asking about incorrect statements. So the right answer is A, C, and D. Question number 5. Presently, 5,000 cars are parked on street in a CBD and there is no parking charge. The outcome from the parking beat survey is as follows. So the beat survey has been conducted at a frequency of 1 hour, right? So for the first hour, 20% of this 5,000 cars were present. The second hour, 25% of the 5,000 cars are present. Next hour, 30%, and the last hour, 25% of the vehicles are observed. Okay, so a study on all the present car users in the CBD indicates that the probability of bringing cars in the CBD may be expressed as P of x equals 1 minus 0.015x, where P of x is the probability of bringing a car when a total of rupees x to be paid towards parking charge. What will be the expected parking demand if a parking charge of rupees 10 per hour is implemented? Okay, so we are going to study the effect of the pricing policy. Okay, so currently without any parking charge, so 5,000 cars are using a particular location. Okay, so 20% of them is using this location for 1 hour, 25% are using it for 2 hours, 30% are using it for 3 hours, and 25% are using it for 4 hours. Okay, so that is the current scenario. So we want to know if we are going to implement a policy where 10 rupees have to be paid for every 1 hour of parking, right? So what will be the demand in that scenario? We expect the demand to go down, right? So without price, it is 5,000. So if we implement this 10 rupee per hour, the number of people who are going to park or park for longer is going to reduce, right? So it will be lesser than 5,000, but we want to find out how much, okay? So, but we are given with this relationship, okay? So what is the probability that a person will, choose uh, to park a car for a certain duration if X is the price for parking for that much duration, okay? So how do we do this? So here what we are given with, let's write that. So here the duration, 1 hour, okay, duration in hours. So 1 hour, 2 hour, 3 hour, 4 hour, okay, up to 4 hours we have done the survey. So what is the percentage of vehicles observed? So we have observed 20%, then 25%, 30%, and 25%. Okay. So what is the total demand? Total demand observed, 5,000. So number of vehicles observed in each for that given duration would be what? So the percentage into the total number of vehicles observed. Okay. So zero point 0.2 into 5,000. So this will be what? 1,000. Then 1/4 will be 1,250. So 30% will be 1,500. Then again 25%, which is 1,250. Okay, so this is the distribution, which means 1,000 vehicles have been parked for 1 hour, 1,250 vehicles were parked for 2 hours, 1,500 vehicles for 3 hours, and 1,250 vehicles for 4 hours. Okay, so this is existing scenario. So now that for the new scenario, what is the parking fees? So for 1 hour, it is 10 rupees. For 2 hours, it is 20 rupees. Okay, so this is the X in the formula. For 3 hours, it will be 30, and for 4 hours, it is 40. Okay, so this is the new policy. So what is the probability of parking? So P of X. Okay, so P of X is what? P of X 1 minus 0.015x. Okay, so which means for the first one, it will be 1 minus 0.15, so it will be 0.85, which means that 85% probability of bringing car, right? Which means if 1,000 people are there, right? So only we can expect that 850 of them will still will still park their car for 1 hour, right? So between 250 people, after implementing this 10 rupee per hour policy, will not choose to park their cars. Okay, so that is for the 1 hour duration. Similarly, we have to repeat it and find the probabilities for other durations. So for the second one, it will be 0.7. So using the same thing, it will be 20 times of 0.015. So that has to be subtracted from 1. It will be 0.7. So it will keep decreasing, 0.55 and 0.4. Okay. So we have got the parking probability of parking. So what is the expected demand? So expected demand would be, so if we call number of vehicles observed is n, so this will be expected demand will be n into P of X. Okay, so 0.85 thousand, which will be 850 vehicles, right? So out of 1,000, now only there is an 85% probability only for parking for 1 hour. So out of 1,000, now only 850 will park. So for the second one, it will be 70% of 1,250. Okay, only 70% of the people will now park for 2 hours. So that is only 875 people. Similarly, for 3 hours, only 825 people will park. And finally, for 4 hours, only 500 people are expected to park after implementing this. So the total expected demand will be the sum of each of these categories, right? 850 plus 875 plus 825 plus 500. So that is 3050. Okay, so 3050 people will still park, okay, use that parking facility after implementing this 10 rupee per hour, right? So initially it was 5000, but now it has reduced by 1950. Okay, so only 3050 people will now will still park. Okay, so that is the new demand that we will have. So by implementing this pricing policy, we have brought down the demand. Okay, so this is one of the ways in which we can manage the parking demand. So this okay. So next one is, so we have to accept or reject the given statement. So the aim of the road safety engineering is to eventually bring down the number of fatal crashes to zero. Okay, so this is a correct statement. So we accept it, right? So road safety engineering is, all these different, measures that we are talking about the reactive approaches, proactive approaches. So these all come under the road safety engineering, right? So where the goal is to reduce the crashes, right? So ultimately we want to have zero crashes, right? So we do not want any fatal injuries, right? So that is the ultimate goal or the aim. So the given statement is correct. Okay, next question number 7. Again, we have to choose the incorrect statement from the given list. So the options are: crash frequency method does not consider the severity of crashes. B, as per Moth report, most of the crashes in India occur due to red light violations. C, visual acuity of a person is important as it plays important role in deciding the color of the traffic lights. And D is increased parking fees may help to bring down on-street parking demand. Okay, so the first statement, A, that crash frequency method does not consider the severity of crashes. This is the correct statement. Why? Because in the crash frequency method, only the frequency of the crashes are taken into account. The severity is not considered, right? So whether it is a minor injury or a major injury or a fatal crash, so that is not differentiated. Only the frequency is taken into account, right? So therefore, the statement is correct that it does not consider. So B, as per Moth report, most of the crashes in India occur due to red light violations. This is incorrect. So the major factor is due to overspeeding. Right, so overspeeding is the leading cause for most of the crashes. Okay, it's not due to red light violation. So B is incorrect. C, visual acuity of a person is important as it plays important role in deciding the color of the traffic light. So this is also incorrect because visual acuity has nothing to do with differentiating the colors. So it is it is to do with how far a person is able to see clearly, right? So in at what angles. So this is going to play a role in deciding where the traffic signs should be placed, right? So it's not going to help in deciding the color. It's going to help in placement of traffic signs. Right, so that's where the visual acuity will come into picture, both in the lateral and the longitudinal placements. The visual acuity should be considered. So, and then final statement D, increased parking fees may help to bring down on-street parking demand. So this is true. Just in the previous question, we saw how this was affecting, right? So increasing the fees will reduce the probability of people choosing to park, right? So which means that overall the demand for the on-street parking will come down. Okay, so that statement is also correct. So the only incorrect statements are B and C. So the answer is options B and C. Okay, next, so this is related to the road safety engineering. So we are given with this. crash database. So that is this table. Okay, so we have to identify the three most hazardous locations, which is the black spot, using EPDO method. Okay, so we are given with some options, so we have to see which of these locations are the most prone to accident, right? So that is what black spot is, right? So the EPDO is one of the methods for identifying the black spots. So what do we do in the EPDO method? So EPDO method, there are weightages given to different injury types, right? And then we take the weighted sum of the injuries at a given location, and then look at that weighted sum to compare between the different locations. Okay, so the weightages are for fatalities, the weightage is 33. For major injuries, it is 15. So for minor injuries, 1.16, and no injury is 1. Okay, so this no injury is the base case, which means there is no injury to the person, but there can be property damage. Okay, so that is our base case, and the others are more severe, right? So yeah, the severity is increasing, so the weightage for those severities is also higher. Okay, so minor injury is 1.16 times as severe as a no injury case. Major injury is 15 times more severe, and fatality is 33 times more severe, right? So this is the weightages. So what do we do is we take weightage into frequency. Okay, we take the product of this weightage and the frequency of the injury type or the crash type, right? And then take the sum for all the different categories, right? So that will be the EPDO value. Okay, so EPDO for a given location is weightage for fatality into frequency of fatalities plus weightage for major injury into frequency for major injury, and so on, right? So for all the categories we have to do it. Okay. So let's calculate the APDO values, because to say, to find out which are the black spots, are the three most severe black spots. So we have to find the ZPDO value for all the locations, then only we can compare. Okay, so let's calculate that. So for EPDO for location A, what is it? 33 times 1, there is 1 fatality, plus 15 times 2, 2 major injuries, and then 1.16 times 1 minor injury, and then 1 times 0, there is um, no injury case. So that will come out to be 33 into 1, 15 into 230 plus 1.16, so 64.16. Okay, so that is for site A. So we have to repeat this for all these sites. For second one, it will be 33 into 2, 66 plus 4 into 15 plus 3 into 1.16 plus 2. So that is 131.48. Then for the third site, the fatality is 0. So 15 times 8 plus 1.16 times 10 plus 4, so that is 135.6. Then for the fourth side, 33 times 1 plus 15 times 4 plus 3 times 1.16 plus 3, so that is 99.48. For side E, 3 times 33 plus 3 times 15 plus 7 times 1.16 plus 0, so 152.12. For site F, 0 fatalities, 3 times 15 plus 1.16 plus 2, 48.16. Then for site G, it is 33 times 1 plus 2 times 15 plus 0 plus 14, so that is 77. For site H, no fatalities, 2 times 15 plus 16, so 46. For site I is 1 fatality, so 1 times 33 plus 1 times 15 plus 2 times 1.16 plus 8, so that is 58.32. And the last location J, 2 fatalities, so 2 times 33 plus 6 times 15 plus 4 times 1.16 plus 5, so that is 165.64. So we have calculated the EPDO values for all the sites. So now we have to just choose the top 3 values, right? So higher EPDO value means it is more, severe, more riskier location. Okay, higher, which means more severe and more frequent accidents are taking place in those locations, right? So higher value means it's a black spot. So we have to choose the top 3 values out of this, right? So 165.64. So this is the first or the highest value, right? So most severe location. Then we have 152.12, that is the second highest value, and the third highest value is 135.6. Right? So these are the top 3 EPDO values, and therefore the top 3 black spot. Okay, J, E, and C. Okay, so J, E, and C. So that combination is given in option C, right? So these are the 3 black spots as per the EPDO method. Okay, so the right option is option C, locations J, E, and C. Okay, question number 9 is you have to accept or reject the given statement. If long-term parking demand is less than or equal to the off-street parking supply, then the vehicle may be allowed to park to on-street facility. Okay, so here we have to look at which type of parking is more suitable. Okay, so on-street parking, and we have off-street parking. So on street, and then we have with respect to demand, this is from the supply side. From the demand side, we have short term parking and we have long term parking. Right? So this is depending on the duration for which the parking is done. Okay. So on street is more suitable for short term parking because this is going to interact with the traffic flow, right? Right, so we do not want to allow long-term parkings on the on-street facilities because it's going to reduce the capacity, right? And also there could be some safety issues also because the traffic flow is also taking place, and some people will be trying to park their vehicles, take their vehicle out of parking. So that those interactions will also be there. So we do not want long-term parking to be allowed in the on-street facility. So on-street parking is for short-term, whereas off-street parking is more suitable for long-term parking. Okay. So here the long-term demand, we are talking about long-term demand. So if the long-term demand is less than the off-street parking supply, right? So we have enough off-street parking for allowing all the long-term demand, for satisfying all the long-term demand. So in that case, the statement is saying the vehicles may be allowed to park on the on-street facility, right? So which means that this is not correct, okay? Because the off-street parking has enough space, right? So to satisfy all the demand which is looking for the long-term parking. So in that case, why should we allow on-street facility, right? So that is not efficient, right? So we should not allow when the supply is there for catering to all the long-term demand. Okay, so in that case, we should not allow the on-street facility for long-term parking. So therefore, we reject the given statement. Okay, then the last question, question 10, is from an in-out survey. Okay, so in-out survey is basically looking at how many vehicles are coming in and how many vehicles are going out, right? So we are not looking at license plate registrations like we did in the previous questions. Okay, so we are only given with the count of how many vehicles came in, how many vehicles left the location in a given duration. Okay, so from such a survey, which was conducted for 30 minutes at a parking area consisting of 80 bays, right? So this is the capacity. The initial count was found to be 65. So when we are starting the survey, 65 vehicles are already present in that parking area. And the number of vehicles entering and exiting the parking area for a time interval of 5 minutes is shown in the table. So every 5 minutes, we have counted how many vehicles came in and how many vehicles left out. And that is given in this table. Okay. In the first 5 minutes, 2 vehicles came in, 6 vehicles went out. Okay. So like that we have for up to 30 minutes. Okay. For every 5 minutes. So we have to find out the average parking occupancy of the parking area and also the parking load of the parking area in vehicle minutes. Okay, so how do we do this? So what we want first is occupancy. So first for occupancy, what do we want? Occupancy is nothing but accumulation by capacity. Right, so capacity is constant, right? So it is 80 bays. So out of this 80 bays, how many bays are occupied in each time period, right? So in each 5-minute time period, how many bays are occupied? So that will give you the occupancy for that period. And then if we take the average over all the periods, we will get the average occupancy. Okay. So what we want to do is find out what is the accumulation, and then from that we can get what is the occupancy. So how do we get accumulation? Accumulation at a given time t is nothing but accumulation at the previous time plus how many vehicles entered minus how many vehicles left. Okay, so this is nothing but the change in the accumulation, right? So if more vehicles have come in than the number of vehicles that left out, which means that then accumulation would have increased, right? So more vehicles will be available in the parking area. If more vehicles went out than the number of vehicles that came in, which means that the number of vehicles that are present will come down, right? So this difference between in and out is the change in the accumulation in the parking area. So we add that change to what was the earlier count. So that will give you the new count. Okay. So what we know is at time 0, right, accumulation was 65, that is given to us. So for the at time t equal to 5, so we know 2 vehicles came in, 4 vehicles went out. So 65, so accumulation at 5 is what? 65 plus 2 minus 4. So 65 minus 2, which is 63. So that is the accumulation value sorry, so this is not 4, this is 6, right? So it is given as 6. So the change is -4. Okay, so the accumulation would then be not 63, 61. Okay, so 61 is the accumulation after 5 minutes of our survey, right? So we have to then calculate this accumulation for every period. So for the 10 minutes, it will be 61, 61 plus 11 minus 4. Okay, that will be 68. So similarly, if you repeat it, you will find the accumulations are 71, 71, 80, and 77, right? So for example, if you see time equal to 20, 9 vehicles came in, 9 vehicles went, right? So number of vehicles that came in equal number of vehicles that left out. So that's why accumulation didn't change between time 15 and time 20. Okay, so now we got the accumulation, but what we actually want is the occupancy. So occupancy would be what? So accumulation by the capacity is fixed. Okay, so this will be what? 76.25. So multiply by 100 to get it into percentage. Okay, so 61 by 80 into 100, so that is 76.25 percentage. So this is for the first 5-minute period from 0 to 5 minutes. So 76% of the bays are occupied. So similarly, we have to find the occupancy for other time periods. So for the second period, it will be 85%. Third period, 88.75. So accumulation didn't change. So occupancy will also not change. 88.75. For the third period, see 80 vehicles are there, right? So which means all the bays are occupied. So 100% is the occupancy. We can't have more than 100, right? So one vehicle only can occupy one bay. So the maximum is 80 in this case, right? So 80 is the maximum accumulation that we can have. So that is 100% occupancy. And finally, we have 77. So that is equivalent to 96.25% occupancy. Now, what is the average occupancy? So we have to take the sum of all this and divide by the number of time periods. How many time periods we have? 1, 2, 3, 4, 5, and 6. Okay. Sum up all the occupancies, divided it by 6. Divided by 6. So you will get 89.17. So this is the average. Okay. So 89.17% is the average occupancy, right? So if you take any 5-minute period, so on an average, 89% of the 80 bays were occupied in the 5-minute period. So that is for occupancy. Next, we have to calculate what is the parking load. So parking load is number of vehicles into the number of hours they were parked. Okay. So that is nothing but accumulation into time period of that accumulation. So here the time period of accumulation is 5 minutes, right? So it is constant for every analysis period, it is constant. So all we have to do is multiply the accumulations by the time periods. Okay. So for the first period, there were 61 vehicles. For the second period, 68. Sorry. For the third period, 71. Fourth period also 71. Fifth period 80, and the last period 77. For each of these periods, the time period is 5 minutes only, right? So therefore we can take it out as common factor and then multiply it with everything. That will give you the total load of 2140 vehicle units. Okay, so that is here 2140. So this is the total parking load for this 30 minutes that we have analyzed. Okay, so that is the answer. 89.17 is the average occupancy, and the total parking load is 2140 vehicle minutes. Okay, here we have expressed in vehicle minutes, not in vehicle hours, right? So it's easy to convert. If you divide by 60, it will become in vehicle hours. Okay, so with that, we are coming to the end of today's session. Okay, so if you have any queries, you can raise it in the discussion forum. Okay, so with that, we will close today's session and then continue again on next week. Okay, thank you for attending.